Hey nurses, for today's video I'm going to show you how Fresenius 2008 K2 is set up here in US. The priming isn't really that much of a difference, but rather the setup itself. So I'm going to discuss that together with some tips and tricks that I discovered while figuring out the difficult alarms to help you equip with a few basic skills and knowledge about Fresenius 2008 K2. So if you are an immigrant nurse who have a pending dialysis nurse job here in US, or just starting a new job and transitioning to a new machine, which is Fresenius, keep watching. Hey nurses, Nurse Rooms here. I'm a Filipino dialysis nurse and welcome back to my channel where I upload videos all about dialysis and my journey as an immigrant nurse here in US. If you're ready, don't forget to click that like button, smash that subscribe button, and hit that bell icon for a new video every week as I take you with me in discovering nursing career. To guide you throughout this video, I'm going to put timestamps in the description below that directs you straight to the topic you are looking for. But before anything else, just a disclaimer, I am not in any way affiliated with Fresenius, and everything in this video is based from my own experience and not intended and shall not be understood or construed as professional advice. Fresenius 2008 K2 is the machine used in my facility. It's a more advanced type than the one used in my last reliever job in the PH, which is the 4008S. Though I have the advantage of being exposed in the same type of machines, but since priming itself is a principle, this is not something you need to worry about. The setup, however, is a huge difference, which I find questionable that it kind of forfeits the principles I learned back in PH. My biggest confusion is how the dialyzer is set up with the blue on top while the red is at the bottom during the whole treatment of dialysis. Because what we practice in the PH is red on top while blue at the bottom. We only do this reversing the dialyzer when purging the air and bubbles out. But in here, it's totally the opposite. So I made some research and it says blue end up dialysis technically is a better option, qualitative and quantitative. Red end up dialysis was introduced decades ago to give cover to the primitive dialysis machines of the past. They were not efficient enough in degassing the dialysate internally. So Fresenius and a few came up with the idea of blue end up as their personal preference and dismissing the red end up logic. This, however, does not offer any defined advantage to the patient. So the principle is definitely the same as long as the dialysate couplings are connected as blue to blue and red to red to keep blood in the dialysate in the counter current flow. Because once you interchange this, co-current flow during dialysis causes 20% reduction in diffusive mass transfer of small molecules in urea and creatinine. The second one is there is no arterial chamber. I was trying to find it, but I couldn't. Then I saw a little round pod with a transducer line, which I figured it might be their mini arterial chamber. On the other hand, for the venous chamber, in the PH, it usually has a transducer line, but here in US, the transducer line is connected to a small round pod, the same from the arterial that is located at the dialyzer end and therefore on top of the dialyzer. Its position makes it really sensitive with bubbles and clot, thereby easily activating the TMP alarm that is the most annoying of all. All this together with the second most annoying air detector alarm will be discussed after this. Both acid and bicarbs are mixed in a huge mixer and distributed to the machines like how the RO water works. Instead of connecting it to a jug, you simply attach it to the wall. This is the screen you'll see first that asks you to select program. The PCTs are not around yet, so the RO is not running, nor the acid and bicarb tanks. So I'm gonna go do this at a later part. Open the NSS. It's packaged as a bag here. Then the bloodlines. The arterial and infusion line are packed together. Separate it to start with the infusion line first. It consists of 2 clamps. Clamp both and connect it to the NSS bag. Next is the arterial line. I usually prime the whole line first before setting this up to the machine. Place the patient's end in the drainage bin, and so is the dialyzer end. Connect the infusion line to the Loctite needleless access beside the arterial pressure pod. Prime the arterial patient's end line by kinking the area between the Loctite needleless access and the arterial pressure pod. Then open the 2 clamps of the infusion line. Once the saline reaches the arterial patient's end, clamp the huge red clamp. Next, prime the arterial dialyzer end line by gravity, releasing the kink and holding the blood pump segment in an upright position with the arterial pressure pod at the bottom. Once saline reaches the arterial dialyzer end, close the top clamp of the infusion line. Don't forget to clamp also the heparin line. Now, place the blood pump segment into the blood pump. Long press the start blood pump button for easy placement and release once done. This type of dialyzer needs to be primed with a full NSS bag. Open the dialyzer and connect the dialyzer end at the bottom. Remove the tapes of the venous line and place the venous patient's end to the drainage bin. Close the clamps of the venous pressure pod and venous chamber. Then connect the venous dialyzer end to the top of the dialyzer. Prime the venous line. Pressing the start button alone will not start the blood pump. You need to press the prime button. Then the word priming will appear in the screen. Don't forget to open the upper clump of the effusion line since we closed this one after priming the whole arterial line. Double check the second also if it is open. I incorporated what I practice in pH here by reversing the chamber to fill it and purge the air out. The machine automatically stops priming once it senses that it's done. If you think it is not enough, simply press the prime to start the blood pump and thereby continue priming. Once the saline reaches the venous patient's end, you can connect the arterial and venous patient's end. But in this case, the type of dialyzer used needs a full bag, so here's the second bag ready once the first bag is consumed. Just keep on pressing prime if blood pump stops until bag consumed. Once empty, stop the blood pump and hook a new NSS bag. Now, connect the arterial and venous patient's end. After priming, the next step is testing, but before I can do that, the bicarbonate acid should be hooked first. Detach the acid and bicarb connectors from the machine and connect to the designated solutions. The widely used solutions are the 2K and 3K, which depends on the doctor's order. Simply turn it on by rotating the switch valves. Select Program on the screen by pressing the arrow buttons and press the Confirm button. Choose Dialysis. The machine will ask to confirm which concentrate. The ordered concentrate is 225123, then confirm. The conductivity limits will then appear, that is red initially, as it tries to load the concentrates. This will turn green once it is within the normal range of around 13 to 15. Typically, when you flawlessly prime the whole setup, the machine itself will automatically show this standby for test message. You can let it test automatically, which will take a few minutes to start, or you do it yourself by clicking the Test and Options button, then choose both tests, which then instructs you to press Confirm to start. If the testing message is in red instead of green, most likely the test will fail. Observe the air detector clamp here is open. The venous line can actually be threaded within it without affecting the testing. So is the arterial transducer line, which I forgot to attach, that should be done before testing. This is how the screen looks like when the test is complete. Next step is to hook the coupling to the dialyzer. Blue up, red bottom. Do not forget to close the cover. Then tilt the dialyzer with the blue end downward to fill the dialysate side. Filling program message will also show in the screen. Also, after the test is complete, the patient ID can now be input. Then select the Prime Recirculation option, then select On. Recirculating message will appear. The venous transducer, on the other hand, should be attached before the recirculation, or else it will interrupt the recirculation, which what this sound means, and goes to troubleshooting again. Don't forget to open the clamp, by the way. Once recirculation is done, the message will turn into dialysis paused. You can now set up the dialysis prescription and hook to patient. That's it. Hope you learned something from this video. If yes, don't forget to click like, leave a comment for some video suggestion, and of course, subscribe to my channel. Up next will be my first birthday here in US. Thanks for watching. See you next video.